Okay, so this is question 1.3. Okay, so for this question, there is a part which has not been covered yet. So you will see in topic 11, which is under called area of sector. All right, so over here, right, this is what we call the sector. So just to a quick mention is that if you want to find the area of sector, basically if I want to find, let's say a sector basically is a part of a circle that's cut off. If I have my theta is in degrees, okay, so the area of the sector basically is like a fraction of the circle. Now we know that one full round is basically 360, right? So this area of the sector in degrees, can be written as theta degree over 360, right, multiplied by pi r squared. So this theta over 360 is as though it's like a fraction, theta occupying a fraction of one full round, which is 360, over the area of the circle, right? That's how I get the area of this sector here. So I'm just going to put this formula here because it's a bit unfair that I have, we have to bring some topic 11 stuff here. Okay, so just be prepared. I'm going to use in part 3, right? This formula here will be used in part 3. All right, so just for your note. All right, so for symmetric property 3, I think if you have read the notes, you know that this is about having a tangent perpendicular to a radius. So if we have a tangent here, this is what we call a tangent. It is a line that touches the circle at one point, right? It will be perpendicular to the radius, meaning that with the radius, it forms a 90-degree angle. Right? So the tangent at the point of contact is perpendicular to the radius of the circle. When we use this, we can also write the reason. The reason is tangent perpendicular to radius, or tan perpendicular to radius, right? So tangent perpendicular to the radius, RAD for radius. Now, I come to question 1.3. So first, I have given that AB is a tangent. The moment I see the word tangent, I will try to think of this property which involves tangent perpendicular to radius. Okay, AB is 8 cm, BC is 5, then OA is equals to X, and also from here we're supposed to find the value of X . Okay, so once I see that tangent perpendicular radius, right, it tells me that I can actually have a right angle here. So angle BAO will be a right angle, right? So what does it mean is even better, I will have a right angle triangle. Right? I know with right angle triangle we can do a lot of things, right? We can basically find Pythagoras, we can think about trigonometry, Tokaso. So first, let me just write it out that for part 1, we must first acknowledge that angle BAO is equals to 90 degrees. All right, so here I'm going to write down the property that we just learned, which is basically tangent perpendicular to radius. Okay, so it also tells us that now triangle BAO is a right angle triangle. This is a right angle triangle. Okay, so then with that, what can we do now is if you want to find X, right, we can use Pythagoras here. So note that when OA is equals to X, OC is actually equals to X, right? Because OC is also the radius. OC is also the radius. So if I use Pythagoras, right, you can see that BA plus OA is equals to OB squared, right? So if by using Pythagoras theorem, this says that BA square plus OA square is equals to OB square. What is BA square is 8. What is OA is X square, which is the radius, and what is OB in this case would actually be 5 plus X square. So with that, you can actually go ahead to solve for X. Right, so let me just expand everything. 8 plus X square equals to A square plus 2AB plus B square. Now very beautifully, our X square can cancel off. We don't have to solve a quadratic equation. This gives us 10x equals, 10x, okay, 10x 8 square, equals to 64, subtract away 25, and then we have x to be equals to eventually 3.9 cm right? So with that, it's done, right? We are done with part 1, right? Okay, so because it's XCM here, I'm just going to put X equals to 3.9. Now let's look at part 2. Now part 2, we are supposed to find angle AOB. Right? Not too difficult because I'm still using Tokaso since it's a right angle triangle. Now since triangle AOAB, right, is a right angle triangle, I can use Tokaso. So if I look at AOB, I can say that this is the same as maybe tangent AOB is the same as the opposite side over the adjacent side. Alright, so I'm just going to use Tokaso. I know that tangent angle AOB is the same as AB over OA. It's the same as AB over OA. Now AB is 8. OB is about, let me see, it's actually exactly 3.9, right? So angle AOB will be equals to tangent inverse 8 over 3.9, which gives me the answer to be approximately 64.0 degree to 1 decimal place. Okay, so with that, we are done with part 2. Now next, we are looking at part 3. Part 3, the area bounded by AB, BC, and the minor arc AC, right? So what are they looking for is they are looking for us to find this shaded area here. This is the part that the question wants. This is the shaded area. They're basically looking for the shaded area here. So how do I find this area? I'm going to take, for part 3, right? What I'm going to do is I'm going to take the area of triangle OAB, subtract away the area that's bounded by this sector OAC. Okay, sector OAC, which is over here. So let me just say again, I'm going to take OAB, subtract away OAC over here in order to find out what's my shaded region. Okay, so remember just now I was saying earlier in this formula, right? What's the area of sector OAC? Okay, so area of OAB, let me just write down. This will be half times triangle, okay, half times base, which is 3.9, times height. This is the area of triangle OAB. Subtract away area of sector OAC, that will be using this formula here. I know that my X is about 64 point something or 64.0 degree. Right, let me just find the real value, right? Tangent inverse 8 over 3.9, 64.0107. Right, so it's like 64.0107 over 360 degrees multiplied by pi r squared. In this case, my r is x, so it's 3.9 squared. Okay, so just to share again, this is a new formula, the area of the sector, which I use and I introduce it at the start of the question, right? So how do we find? We call this a sector, right? It's like basically like a bit of a fan out from the center of the circle with 2 radius as a boundary. To find the area of this sector here, we can use this formula here, which is theta. Theta is basically this angle here over 360 multiplied by pi r squared. Okay, so taking the area of the triangle, subtract the area of the sector from here, then I can finally find my answer. So part 3 answer should be about 7.10 cm squared. Okay, so I hope you understand. If not, just slow down my video and watch it again. Okay, thank you.